Welcome back to another episode of Thinking Critically. Today, I am joined by twins. The first one, Dr. Perry Zurn, who is a assistant professor of philosophy at American University and affiliate faculty in the Department of Critical Race, Gender, and Culture Studies. He researches in political philosophy, critical theory, and trans philosophy, with special expertise in feminist philosophy, philosophies of resistance, and network theory. The other twin, I have Dr. Dani Bassett, who is a J. Peter Skirkanich Professor at the University of Pennsylvania with appointments in the Departments of Bioengineering, Electrical and Systems Engineering, Physics and Astronomy, Neurology, and Psychiatry. They are also an external professor of the Santa Fe Institute. Bassett is most well known for blending neural and systems engineering to identify fundamental mechanisms of cognition and disease in human brain networks. So both have authored numerous books and publications, including their most recent book, which they actually authored together, Curious Minds, The Power of Connection. Anyway, Dani and Perry, thank you so much for joining me.
Delighted to be here.
Yeah, absolutely. This is wonderful. So I think this is the first time that I've had authors come on jointly who have co-authored a book together. But number two, you happen to be twins, siblings.
Yes.
Which is really interesting. We'll dig into that in a second. But first thing that I do, because I'm always interested when I have a conversation with scientists or other people as well, or philosophers such as yourself, Perry, I always just kind of want to hear how it is that you found yourself studying what it is that you're studying. So, for example, Perry, where did your interest in philosophy come from? And Dani, where did your interest in science originate from? So, Perry, maybe we could start with you.
Sure. Yeah. We both grew up with being homeschooled from kindergarten through 12th grade, and our experience was really interdisciplinary and very sort of wide-ranging and free. I did encounter some philosophy in high school in that way, but I really encountered philosophy in college. And the minute I had actually come in as a pre-med student, and then I took one of these, gen ed filler classes, and it was a philosophy 101 class, and it just blew me over. And I haven't stopped since. And I think for me, the core of what's fascinating about philosophy is that you get to pause and consider commonly assumed concepts or arguments or perspectives or worldviews, and you get to say, wait, is that really how it is? Is that really what we mean? Is that really what we want? And I just love that. I love that capacity to kind of step back from things and take a new perspective on them.
Very interesting. And so for you, Dani, where do you think your curiosity came from? So obviously you grew up in the same household as Perry, so you were able to explore all of these different areas, very interdisciplinarian, like Perry said. But why do you think you gravitated more towards science and physics in particular?
Yeah, I think it's a really good question. So initially, when I was a kid, our father is an orthopedic surgeon, and he would come back and he would learn new surgeries by watching videos using a VCR, these videos would demonstrate how to use particular tools to do a knee surgery, for example. And I remember sitting next to him and being fascinated by the human body and medicine, how medicine can actually change the human body in a way that's beneficial to us. So initially, my interests were actually in medicine. I started out in nursing school, and I did that for a year and a half towards an RN degree. But I quickly realized that there were parts of that career that I highly respect, but that were very difficult for me personally. And so I decided to move to Penn State University and initially signed up in mechanical engineering, and I'm still wondering why, but then took my first physics class and sort of like Perry, just couldn't look back. What I find fascinating about physics is the fact that so many things in our world are so incredibly mysterious. But what physics does is that it says, here's this amazing mystery like magnetism, but we can write down very simple mathematics to explain why it works the way it works and what it is. And it's something about that juxtaposition of mystery and simplicity, or maybe complexity and simplicity, that I am just enthralled by and really love.
No, that's really interesting. That you mentioned that you went in as a mechanical engineer, Dani, and then ended up transitioning to physics, because I actually had a very similar sort of academic journey where I initially started school as a mechanical engineer as well. And I didn't immediately transition into physics, but I had always had an affinity for physics. Well, I love science in general, but I'd always had this pull towards physics, but didn't really think that I could do it from a mathematical standpoint. So I ended up transitioning into geology after doing a year in mechanical engineering, because I knew I wanted to do science, not engineering, and then eventually transitioned to physics in graduate school after I'd taken a bunch of math courses. I'm like, I can do this. So I had a very similar journey.
That's really neat.
In that aspect. Yeah, and one of the things that I love about physics is like what you just said there. It's that you have all of these questions out there, and physics oftentimes is able to boil it down to these very simplistic, beautiful mathematical expressions to explain these wonderful phenomena, such as you had highlighted magnetism. So yeah, as you can tell, Perry, I'm a bit of a physics nerd too. So
that's great. I love physics nerds.
I do love philosophy as well, don't get me wrong. But I definitely gravitate more towards the physics stuff and the science aspect of things. But anyway, your stories are completely fascinating, and in particular the homeschooling aspect of it, I was super intrigued by, and because there have been debates back and forth, for as long as I can remember about public education versus the homeschooling system, or excuse me, a homeschooling education, and looking back on it as two individuals who have done quite well academically, I'm curious if you think that you'd be in a similar situation if it wasn't for the unique education that you had growing up.
Yeah, it feels impossible to predict what would have happened.
Yeah.
In fact, I just recently finished reading a book on the lives that we haven't led but could have led, which was just fascinating thing to think about. But I do think that our upbringing provided us with a really unique perspective on learning and experience in learning. So one of the things that our mom did is that she would invite us to take a really active part in developing our curriculum. So she would ask us what we wanted to learn that particular semester. And then she would go and find books that would help us to learn that particular area. But the content, the sort of focus, was something that we defined. And I think that opportunity to define the questions that we were most excited about, I think, helped us to grow in these skills and ways of thinking that are very consistent with what you do as a researcher, right? And so as a researcher, whether in philosophy or in science, you're constantly asking, what question am I most excited about? And then finding a way to unpack that question and get answers. So I think that bit that was instilled in us quite early is something that we've carried through till now. I don't know, Perry, if you have additional thoughts.
Yeah, I mean, I think it absolutely helped us to become the researchers we are today. But I also think that it gave us such a sense of empowerment about our own learning and a sense of disregard for disciplinary boundaries that we have both been, in some sense, chastised at various points in our life by our own disciplines to say, well, that's not really what you should be doing in this field or in this field, or that question isn't relevant. But I think for both of us, it's been we early on, I think our mom instilled in us this capacity to again say, yeah, where do I not only what is the question that I'm really excited about, but where are the resources? And if the resources to answer that question aren't currently in my field or in the methods established in my field or in adjacent fields, fine, I'll keep going, right? I'll keep expanding out to go find those necessary resources and methods and tackle the questions most interesting.
Yeah, what I find most fascinating is what you just said there, Perry, how your upbringing has been influential in, and correct me if I'm wrong here, but kind of pushing the boundaries. And like you said, the very interdisciplinary nature of what you do now academically. And I love it personally, because I think that the blending of these various disciplines is really important to advancing knowledge. I think that there's a lot to be learned there in the spaces in between disciplines. So yeah, in the field, this kind of ties into the field of, and I know that Dani, you do research in the area of complexity and that you're involved with the Santa Fe Institute. And I absolutely love all of that. So I find that the most fascinating aspect of your unique upbringing to you is the fact that you are able to now push these boundaries and you feel free to do it, even though you're getting some pushback, you said. So I think it's pretty awesome.
We enjoy it.
Anyway, I'm super curious, believe it or not, to hear about your most recent book here, Curious Minds, and why it is that you felt compelled to write it in the first place.
I think we were in a position where we were starting to generate really big ideas in our own fields, but felt really lucky that we were both in academia and we're both headed into positions, more permanent positions in academia, and we just, we loved growing up together. We loved talking together about intellectual things all our life, and so we just thought, it'd be really great if we could centralize that in our careers too, right? And it didn't just have to be this side thing. So I think we were looking for a concept for a book to write together, and really wanted that experience of writing a book together. And I was, writing a PhD on curiosity and philosophy, and Dani at the time was publishing on flexibility of brain networks. And the more I read and heard about this flexibility thing, I said, I really think there's something here that could connect to curiosity and what it is that's happening perhaps in the mind when we are curious. And at that point, Dani, if you want to jump in.
Yeah, well, so then we started talking more about understanding the mind from the neuroscience perspective, which I bring, and the philosophy perspective, which Perry brings. So understanding the mind, and also specifically the curious mind. And as we started those conversations, we began collaborating in earnest. So much of the work that is described in the book is from scientific articles or philosophy articles that we've written together over the last 7 years. So we're really building a research archive as we began our discussions, and that became what we now have in the book. And as we were doing that work and excavating those ideas, I think we realized that I realized that philosophy actually has a lot to offer scientists in defining what curiosity really is, or what it could be. And I think likewise, Perry has found that science, and particularly network science, provides a new language that can change the conversation in philosophy around what curiosity is. So we realized that our two disciplines could really, by coming together, not only do you get a beautiful gel of ideas, but you also kind of cross-pollinate the two fields in really important ways that pushes the conversation forward.
Very interesting. So you've been working together for approximately 7 years now,
Yes.
cross-collaborating. Oh, wow.
Yes.
So I know that, so I grew up in a larger family and I have siblings. I don't have a twin, so I don't know what that's like being a twin, but I know that I tend to butt heads with my siblings sometimes. So has there been some spirited conversation back and forth over the years about when you're collaborating on research?
There's definitely been some spirited conversations, but I don't know if they're that kind of conversations. As children, we had a lot of competition between us, and there was a lot of butting heads when we were children. I think that now I find, I don't know. I don't feel conflict with with Perry. Perry's my best friend.
Well,
so
no worries. I was trying to more kind of highlight that, within science or philosophy, or when you're trying to dig into the heart of research problems, that there's always conversations that need to be had. And sometimes some are a little bit more tense than others. I didn't know if the sibling aspect of that, played into the research collaboration at all. That's all. I was just curious about that.
Yeah, I don't think it does. I think that we come at it with a huge respect. I mean, you know, network neuroscience and philosophy are really different and developed
Yes.
as really different fields. And so in that sense, we deeply respect what each other's bringing to the shared projects that we have, and are really our conversations are more gleeful than anything. A sort of
Okay.
like, oh wow, that's what y'all are talking about. That sounds like what we're doing over here, or like what we're doing over here. What would that look like for you all in the sciences? And we're just, it feels like we're discovering all of these resonances, and that's just thrilling.
Wonderful. Wonderful. So you've been collaborating for 7 years. You've published a number of articles together, and then you've kind of compiled all of them and put them into this fantastic book, which I do a lot of reading. I mean, as an academic, reading research papers. I do a lot of reading in my spare time. I have a number of authors on this podcast to discuss recently released books, so I have to read their books in order to prepare, such as what I had to do for today. And I haven't read a book like this in a long time. It is remarkably diverse. It attaches all these different aspects of science and philosophy through this network, this webbing. And I'm not, maybe it's both of you or one in particular, but thank you for expanding my vocabulary. So yeah, the vocabulary that was used in the book, I mean, there were some words that I had never heard before, and I've read a lot of books. I've read a lot of works, and I just thought it was fantastic. And the ideas are wonderful, and just the way everything was connected together. I mean, it was very, very interesting. And this whole idea of being able to study from an empirical standpoint, curiosity, and yeah, it's just fascinating. So let's go ahead and dig in. Let's start with in the beginning of the book, you kind of dig into the science of curiosity and what exactly it means to be curious and how that fits with the scientific method.
Yeah, exactly. So just a quick comment, maybe to circle back to that earlier point that you were making about the way that the book is written and how we pull different strands in from lots of different places. That was very purposeful in a way of demonstrating the kind of curiosity we're talking about in the way we're writing. So we are purposefully laying down these threads and pulling on different fields in a very diverse way to kind of illustrate this very expansive curiosity that we're talking about. So just a quick note that style of writing is very purposeful as an example of the ideas. And then about the science of curiosity. So what's interesting about the science of curiosity is that what we typically do in science is try to identify, what the question is, what the parts of the question are, what are the key variables that are important in answering a specific question or a hypothesis, and then developing experiments that will help us to address those variables. So what we talk about in that first chapter is thinking about science and the scientific method as pulling apart the pieces of a sentence, finding all of the parts of speech. What is the noun that we're excited about? What does the noun do? Okay, that's the verb. What does the noun do in certain spaces? Okay, that's the preposition. The sort of separation of questions in science into these parts of speech actually helps us to write down mathematically what the model is that we would want to use. And so that's I think, key relationship between curiosity and kind of the scientific method. But then we also move into ideas of where does curiosity lie? If that's the noun, if that's the thing we're searching for, where do we find it? Is it in the body? Is it in the heart? Is it in the feet and the hands that like pick things up? Is it in the mind? Is it in the brain? And we talk about how you would attempt to develop experiments that would identify curiosity if it was in each of these places. So if it was in the brain, is there a particular piece of the brain that's the curiosity piece, right? And then if that's the case, then how does that curiosity piece talk to the piece of the brain that moves your hand to pick something up, or that directs your eyes to notice something in the corner of your view, or makes you focus on, your ears hearing an odd sound that comes from across the field. So we ask questions about how to identify what the pieces are and then how they would come out into the rest of the body. But at the end of the chapter, or at the end of that sort of piece of the puzzle, we note that the scientific field right now has questioned whether it's even possible to define curiosity. Is that even a worthwhile goal? Or should we just be studying human behavior and its methods of inquiry without trying to state any definition, without trying to identify the variables or write down a mathematical model? Just let's just watch humans for a while as they're searching for information, and we'll define curiosity later. Is basically what a group of scientists are suggesting. And that made me as a scientist pause and say, are we stuck? Are we at a place where we can't define curiosity? And if so, are there fields outside of science that could help us to define it better and in a way that is practically more useful in developing new experiments? And that's really where this germination of interdisciplinary work with Perry began, because I think I'm convinced that it's in philosophy where the definition of the curiosity is most fruitful right now, and that going into philosophy allows us to come back out to science and say, with a philosophical account of curiosity, how does that change our experiments, and how does that change how we think about the mind?
Very interesting. Very, very interesting. So, okay, so science can't definitively define curiosity, at least up until this point, prior to your work. So then you had to dive into philosophy. And this has often happened in the past, where you have philosophical underpinnings directing scientific experiment in order to define curiosity. Okay,
yeah,
fascinating.
And I think what's important about that maybe is to recognize, as a scientist, I understand that the majority of our work focuses on humans who are alive today and the ideas that are present right now. But curiosity, and the mind are things that have been around for thousands of years, right? And so what's really interesting is that science typically isolates itself to ideas that are present today, without really recognizing the fact that there's a history of those ideas that could help to change or flex the accounts that we're currently using. And so that's where I think philosophy, and specifically the history of philosophy, can come into play, because then we can say, how has the mind been thought of for 2,000 years? How has curiosity been thought of for 2,000 years? Are those accounts being used to their fullest measure in science right now, or are we really just focusing on a tiny slice of them that we felt was accessible to scientific inquiry? And I think usually it's the latter. We're focusing on this tiny slice of an account of curiosity, a tiny slice of the account of the mind that seemed, accessible to science, but we've kind of forgotten or not expanded our minds to understand that history that could be so useful in better constraining our models.
Yeah, no, I agree, absolutely. And we definitely don't want to constrain ourselves. And you don't want to, because at some point you're tossing out valuable information when you're constraining, when your scale isn't appropriate, and you're not able to perhaps have as accurate of a worldview or a idea of the situation as you possibly could if you just kind of expanded your boundaries a little bit.
Yeah, exactly.
So one thing you also said in the beginning of the book that I found was really interesting, kind of on that topic about scale and not limiting kind of the information, is that there was a mention of how reductionism or absolute reductionism doesn't necessarily work So I was wondering if we could explore that topic just a little bit.
Yeah, absolutely. So reductionism is this approach that takes a complex system and says, let's understand each of the parts and what each of the parts does. And it's a decompositional approach. It says, here's the composition, here's the complex system, let's decompose it into its pieces and understand what each of those pieces are. However, it's really important to recognize that even if you understand what the pieces are, you've reduced it to the pieces, that's reductionism. And even if you understand what the pieces do, that doesn't mean that you know how to put the pieces together to build the complex system that you started with. And so the pieces are often, they don't necessarily hold the key or the secret to how the thing works when it's all put together. So there has to be the sort of decomposition is distinct from and not redundant with the recomposition. And so that's kind of the mystery of the recomposition that becomes important. So yes, we want to understand the pieces. Yes, we want to understand what each of them does. In this case, it's the mind, the pieces of the mind or the pieces of the brain. But then we also need to understand how those pieces come together to form the mind or to form the brain and to support our curiosity. So it's that expansive upward motion that remains critical and remains important to understand, and that's beyond the boundaries of reductionism.
So I absolutely agree with you, but I think that there might be some particle physicists out there who don't agree with us, who think that absolute reductionism is the way that science should be done. And I actually think that there's room for both. You want to have reductionism because you want to break things down into their little bitty parts as much as you can to try to understand how things work on the most fundamental level. So in this instance, I think particle physics is probably the most fundamental that we can get, or yeah, exactly, particle physics, or I was going to say theoretical physics, but that deals with particle physics. So, or quantum gravities. But then as you build things up, systems change, which is why we have different sciences. So as a physicist, Dani, you'll understand that you have quantum mechanics, then you have statistical mechanics, and then you have relativity. So you're talking about all these different scales. And once you reach a certain threshold, you have new physics, or you have a new physical type of framework that you need to use in order to understand what's going on. So it's this sort of emergent properties that come about when you have more and more stuff interacting with one another.
Yeah, and it's actually exactly those emergent properties that I think require us to go beyond reductionism, because emergent properties are properties you can't predict from the pieces. And actually, maybe that, just to circle back for the audience, that is a large part of complexity science, is understanding how really complex functions emerge from systems that have lots of little pieces. And that's a domain that I've found exceptionally exciting for as long as I knew about it.
And how does that tie into curiosity? Maybe we can expound a bit on that. I know you briefly mentioned that a little while ago, but with curiosity, you're talking about the little bit in this instance, you were talking about kind of the brain and the smaller functions, or maybe like ideas, just little bits of ideas and how they branch out into curiosity.
Yeah, and I think that's where network science comes in, which is that we want to understand how the pieces of the brain are connected up together and share information with one another, and how understanding arises from that interconnected pattern. And that understanding and curiosity are both facets of the human mind that are not explainable by isolated pieces of tissue. They require this more connected approach, which is part of the reason why we called it the power of connection. However, I think this focus on connection, 2 points I want to make. One is that the focus on connection is important for explaining how complicated functions emerge in the brain and in the mind, but it's also really important for understanding curiosity as it relates to how people interact with one another in social and other broader settings. But I think that whole story of where the connectivity comes in and how that helps to explain complex functions really came about by talking to Perry about the philosophy of curiosity. So that's a key piece of the puzzle that sort of then comes into the network story.
And while we're on the topic of philosophy, Perry, let's kind of dig into the philosophy of curiosity. And you just mentioned Dani, so that's where the philosophical component comes into play, the network science. So let's go ahead and explore it. So go ahead, Perry.
Sure. Yeah. So in the philosophy of curiosity, we get to build on thousands of years of philosophers talking about curiosity. One of the things that's interesting is that philosophers haven't really written books on curiosity. Curiosity has been this sort of peripheral thing that folks write a chapter here or a paragraph there throughout the history. So it's regularly shows up throughout the history of philosophy, but there's not like tomes about it, which just says there's a lot more we can do. But throughout that history, one of the things you see is a consistent characterization of curiosity as this desire to know, or this capacity to explore, or this ability to grasp new information. And we end up in the book characterizing this story as an acquisitional account of curiosity. Curiosity is seen as a capacity through which I can acquire information. I can gather up all this information, and then it's mine, right? I get to hold it in some sense. And this account has informed really the bedrock of psychological studies of curiosity, and therefore neuroscientific studies of curiosity, because those have really built on the psychology. So neuroscience is built on psychology, has built on philosophy's definition of curiosity as this capacity to grasp new information. But this is a limited account because it centers the individual, and because of its acquisitional quality, it doesn't allow information itself to have its own relational world in which we're relating to it. Rather, it's just the knower who goes out and gets the things they want to know and then does things with that knowledge. It's very individual focused and kind of enterprise focused. We end up proposing, and one of the things that I saw as I returned to all of these kind of accounts of curiosity, there seems to be another story of curiosity underneath and kind of to the side of that primary story. So if we think of the primary story as being told by St. Augustine and Rene Descartes and John Locke and folks like this, we can see, for example, in John Dewey, a different story of curiosity, where curiosity is this capacity to connect and this drive to connect what I know and to what I don't yet know, but also to connect me to my world, me to my surroundings, me to other people, right? Curiosity is this drive to build connections of knowledge and of social relations. And that also means this connectional account of curiosity then allows us to think about curiosity not as this individual capacity so much as this driver of social knowledge, social and global knowledge, and kind of world building that we all do together. And it's precisely that account, I think, that has so much resonance with a network science, but it also gives us a lot more resources to use curiosity to think about the challenges that we all face together in our shared worlds and in our shared worlds of knowledge.
Now, what you just said there about thinking of it as networks, I am just really curious as to how philosophy explores that. I know that you kind of touch on that in the book a little bit, but I'm coming at this more from a scientist perspective, and I've read into network science, but how does philosophy explore networks? Like on a more, I guess, on a more technical level, how do you explore a network in philosophy? And then perhaps we can relate it to the work that you've done with curiosity.
Sure. What's helpful to know is that network science is really built on earlier versions of network social science, so sociology in particular. And even before that, so if we're talking about around the 70s, there's a lot of theorists, philosophers, theorists, etc., who are writing with the language of networks in the 70s and sort of around there. So it's easy to start there. If you want explicit reference to networks and how it is that philosophers are thinking through networks, 1970s is a good place to go. One example is Fernand Deligny, who is a French theorist who worked a lot with children with autism, and therefore he's focused on education, but especially for neuroatypical folks. But he writes an entire treatise about that's called the Arachnean, and it's about web making of knowledge, how we make webs of knowledge, and he uses the language of networks all throughout this. And he's writing in the 60s and 70s. And he says this is particularly helpful. This approach of thinking about knowledge as webs or knowledge as networks is particularly helpful if we're trying to reimagine education for neuroatypical, or in his language, students with autism specifically. So it's the resources are there, and the language is particularly compelling. Of course, it's not formalized into scientific or mathematical formulas, and is not applied in any experimental sense, because that's not what philosophy and theory do. But we do explore concepts, and we explore the relationships between concepts and the ways we could rearrange our ideas that would help open up new ways of thinking things. And so we have a network philosophy in that sense.
Very interesting. Yeah, I'm fascinated by philosophy, and I was just really as I was going through your book, I was just trying to figure out how exactly you differentiate between the philosophy of networks versus what is done in network science, besides I suppose the experimental aspect of it. So of course philosophy doesn't do experiment, but like, how do they influence each other? So yeah, well, thank you for answering that. Yeah, I was just super curious to try to dig deeper on that particular topic.
Yeah, I mean, I would also just say there should be more work here between network scientists and network philosophers. I think so the reason that you're not quite sure how that would work is because there's not enough work there. So that it's an opening, I think, that we're stepping into, but I hope a lot of other folks are as well.
Well, yeah, thank goodness you two are exploring it, right? So we have the scientist in network science working with the philosopher in network science. So yeah, so help fill the gaps, or explore that area with your curiosity, right? All right. So okay, so if we're looking at we're dealing with this network paradigm for curiosity, how exactly do you? So within networks, you have the nodes, and then you have the edges. And this is a concept that's explored in your book. And you say that curiosity is edges. And I don't specifically recall what the nodes are. I think that has to do with the unit of thought, which leads to the curiosity on the edges. Correct me if I'm wrong here, but how exactly does that all work? So I can't recall it exactly.
Yeah, so the idea is, so if this philosophical account of a connectional curiosity has legs in the scientific world, then what we would need to do is to isolate what the pieces are, and then what the nodes are in the network, and then what the edges are, what are the relations. So in the context of thinking, the nodes could be a particular thought. It could be a concept, which is fairly small, could be an idea, which might be a little bit bigger, could be a whole thought, which could be a little bit bigger. And then you could get to questions about, well, what is the size of the thought, right? I don't know, is it what I'm thinking right now in 2 seconds, or is a thought something that I've really had for 10 years? So this brings back your scale point earlier, which is that there are many different scales at which we can define the size of the node when we're talking about curiosity. The thing we're interested in could be very small, could be very large. Even in the context of language, you can say, well, maybe the node is a sentence, or maybe the node is a clause, or maybe the node is a word, or maybe the node is a sound at the beginning of a word, or syllable. There are many different scales where we could usefully be building networks. And then what is the edge? Well, the edge in the context of an idea is a relationship between two ideas. And to illustrate, that still might sound really abstract, so I want to give an example. So how does the mind show that it has relations inside of it, or networks inside of it? The easiest way to see that for yourself is to do what's called a free association task. And What that is that you pick a word, any word that you want. I'm going to pick keys because I have the keys for my car on my desk here. So I'm going to pick keys, and then from keys, I need to move to something else that comes to mind right afterward. Okay, and I'm going to do this for a couple words. So I'm going to start with keys, and then once I think of key, I think of car, and then plane, and then clouds, and then rain, and then rivers, mountains, glaciers, climate change, climate in businesses and educational institutions, maybe cultures of inclusion or diversity or equality and justice. Maybe then I would go from justice to the Supreme Court, and then I would think of Ruth Bader Ginsburg, and then that leads me to icons, feminist icons specifically, and then I'd go from probably Ruth Bader Ginsburg to Virginia Woolf, who's one of my favorite icons. Okay, so in those few words, I've gone from the keys on my desk to Virginia Woolf, right? And that feels like a wildly huge space to have covered, but you can tell from each of those steps that there was a relation. There was an edge that connected keys to car. I know the relationship between a key and a car. I know the relationship between rivers and mountains. I can tell it to you, and you know it already. You know the relationship between mountains and glaciers, between glaciers and climate change, between climate change and etc. So each of these steps is explainable by an edge, a relation, and each of those words would be a node. So the fact that I can do free association and that any audience member can do free association indicates that there's a network in our minds that has a pattern of relationships between ideas or concepts. And it's that pattern that we're really interested in exploring. We want to know how it got there. We want to know how it grows. We want to know what happens when we have different kinds of curiosity. Does that pattern grow differently? Do we each have different patterns in our minds? And is that because we're curious differently from one another? So those are all sort of the questions that come up as soon as you think about the fact that that knowledge is really sort of a network structure that we seek, that we build over our lifetimes, and that we build by curious actions or curious practices.
So you would describe those chains, so the edges. So you have each of the nodes that you connected, and then the edges. Why are you convinced that those edges are curiosity? I mean, I agree that you could label it as curiosity, but I would like to know why it is that you think you're like convinced that that this edge in particular, when you said all those various words that connected, that it was curiosity that got you there.
Yeah, in that free association task, those edges are, I think, an indicator of past curiosity. It's not necessarily of my curiosity right at this second. So it's an indication more that there's a network structure in our minds. And then the question of curiosity is more about the question of how that network got there. So I like what you're asking. So let's think about that for a second. So why is it that we say that curiosity is this edge-like action? Well, it's because when I think I'm seeking information, I'm not necessarily seeking a isolated piece of information that isn't connected to anything else. I'm seeking something because of its connections. So I am learning about a new field, and I realize that there's a piece of the field that I really don't understand. It's like a hole inside of my network, right? And I know the ideas that are around that hole, and I know that I'm missing a piece of the puzzle. And what I want to do is to find that piece, and I'll know that that's the piece when it connects to everything around it in a way that's understandable, right? So it's that connection becomes important. I want to contrast that view, that connected view, with imagining that curiosity is really about finding the nodes themselves. To find an isolated node with no connections means that you know absolutely nothing about that node. You don't know, you can't understand any of its shared relationships with anything else. There's nothing about that node that you understand. You don't know any single piece of it. Well, if that's the case, then that node is for example, a word in a language you've never heard before, or it's a, something from a planet that you've never visited, or it's from an alien culture that you've never been exposed to, and you wouldn't even know that you saw it when you saw it because you don't know anything about it, right? So it's this like isolated nothingness out there. It also wouldn't be useful to you for any reason because you don't know how it relates to anything else. There's this wonderful, I think it's Dewey actually, who has a passage in one of his books, Democracy and Education, where he says that knowledge is such a pattern of interconnections that any past experience can offer a point of advantage from which to get at the problems presented in a new experience. And what he's underscoring here is that any piece of knowledge that you have, anything that you've learned, necessarily relates to something that you knew before. Otherwise, it's not knowledge or not something you can grasp or even seek. And it also predicts something about the future, or about what you could know, or it might change your decisions about what you might do in the future. So it's always connective in this backwards connection and forward connection manner. If what we were seeking was this completely distinct, independent thing, we could never do anything with it. It doesn't help us to understand the past, and it wouldn't help us to do anything different in the future. So that's why I think it has to be connective, because knowledge is connective.
Mm-hmm.
And I would just add there that we talk about curiosity as edge work. So working certain edges, which on the one hand means laying down these edges or these relations between what we know and what we're coming to know, building those edges, literally laying down that thread. That's part of what curiosity as edge work is, but it can also mean removing certain edges. So all of us in each of our fields, we know and or have done this ourselves, right? That there are certain connections the field has made that have had to be disconnected, right? We thought these two things were related in a particular way. Now we know they're not. That happens in every field. So the edge work is and that's driven by curiosity, right? We're looking at this edge and we're looking at this relationship, but we're testing different things out and we're saying that's not working. It's not working. I think it's this edge. It's this connection we've just taken for granted. We got to lift that up. We got to put that down somewhere else. So curiosity as edge work is, I think, a helpful term.
Yeah, I like the way that you frame that, Perry, where it's you're breaking down and building up and restructuring these knowledge networks. And the title of the title of that chapter, I think, is Curiosity as Edge Work. So yeah, definitely having to break down, build up, and reform these networks. One thing I did want to ask, though, when you were talking about how, and Dani, you had just mentioned that knowledge doesn't make sense unless it's connected to the past, and then you had referenced a passage from Dewey. How does new life, I guess, fit into this framework? So for example, a developing mind, so a individual that is just born and learning brand new things about the world, so they don't have any prior references. So are they naturally, like, instinctually curious about the world? Of course we need to learn things in order to survive, because if we don't learn how to feed ourselves, if we don't learn how to protect ourselves from danger, we don't grow up and become old enough to pass on our genetics, which is something that all animals must do. So I'm just curious if you've ever thought about that.
Mm-hmm. Yeah, I think that's really important. And actually, in the study of infants, there's a particular kind of implicit or passive learning that occurs, which is not necessarily the infant seeking something, although that also happens, but that the infant is exposed to information and passively acquires knowledge about the world from that exposure. So I want to sort of make a distinction here between the active soliciting of knowledge from our external world and the passive observation from just being exposed to lots of information, right? And so for infants, when they're exposed to information, particularly about language, when they hear people around them speaking, they will very quickly, what they do is that they sense dependencies between phonemes. So a phoneme meaning a piece of sound of a word. So what the infants will do is that they'll hear, oh, here's a sound that I've heard before. It very frequently comes next to this other sound, and less frequently comes next to this other sound. And so they begin to learn the how probable it is to transition from one sound to another. And it is breaks in that transition pattern that signal to them the separation of one word from another word. And that's how they build their vocabulary. So this is called statistical learning. They're learning from just being exposed to the sounds and recognizing how probable it is that one sound will transition to another one. There's beautiful work showing that that kind of statistical learning is a network learning, actually. It is an understanding, an appreciation for the patterns of connections between phonemes, and that's how infants learn. But it is much more of a passive approach than something that is, I'm an adult and I'm seeking out this piece of knowledge that I know is missing in a hole in my understanding of relativity.
And that, that happens socially too, right? So we acquire a full-blown network of social values and explanations of the world and our relationships to one another without passively, as you're indicating, simply by by the time we're 2, probably, or maybe even before, right? There are studies that demonstrate that young people already have a sense of what's right and wrong at, I don't know, infant level. And they're acquiring that slowly, and all of us are. And this is, I think it's an invitation, obviously, to rethink the things that we've acquired passively, the networks of values socially that we've acquired passively, and to sometimes put them to this kind of more active test. Well, do we really want to? Let's uncover them, and then let's ask, do we really want to organize ourselves in that way?
Yeah, it's a very interesting distinction, an important one as well, like you said, Dani. I'm curious, in the passive learning, you said that also there's evidence for networks. In that instance, what do you think the edges are? I don't know if there's actually been any research into trying to define the edges. Please feel free to speculate at this point. I mean, if there's no work that's been done.
Yeah, no, the edges are transition probabilities. So that means the probability with which something transitions to something else. And in language, it's a phoneme transitioning to another phoneme. But we also use the same kind of approach for understanding visual scenes, in which case the nodes are going to be events, and the transition probability is the probability that one event transitions to another event. We learn that this common example here would be the relationship between thunder and lightning, right? Those are 2 different events, and there's a very well specified transition probability between them based on how thunderstorms work. So that's what the edges are. Okay,
very interesting. And so knowledge networks, and you had touched on this earlier. I don't know if it was you, Dani, or you, Perry, where you're talking about the various shapes that, as we learn, we have different learning patterns, and there's different styles. And the way that these knowledge networks organize themselves have different morphologies or topologies, if you're talking about like graph theory or something like that. Now, you had talked about in one of your chapters that there's particular styles, that there's 3 archetypes. So you have the busybody, the hunter, and then the dancer. So perhaps we could talk a little bit more about these 3 archetypes that you had identified through your work.
Sure, yeah. One of the questions for me early on in my study of the philosophy of curiosity was to think about curiosity not as this kind of light bulb that I carry inside me, but rather as something I do in the world, or something each of us does in the world. Curiosity is a kind of practice, and it's something that we can practice. So then the question is, what are those practices? What does curiosity do? And as I went back across to revisit all of these passages in the history of philosophy, specifically Western philosophy, because that's how I'm trained, I was looking, I at one point I looked for all the definitions of curiosity and then just got frustrated, and then decided let's look at the descriptions of what curiosity looks like in practice and what might I gain from all of those descriptions. And it was so interesting to me that over and over and over again there were sort of these three pockets of descriptions of curiosity across thousands of years in multiple continents, and that seemed kind of surprising and worth pausing over. So these archetypes, the busybody, for example, is someone who loves to learn about a lot of different things, just has this really wide-ranging interests, and in that sense builds their knowledge networks very sort of generously. I'm happy to kind of make this connection to this and this connection to this and put this in my kind of constellation of knowledge sets. And I'm not a purist. I'm not trying to like reduce my interests. I'm ready. I'm just a ready learner, right? So that's a busybody. And then the hunter is someone who's far more focused. And there's a lot of language specific. When I talk about the hunter, I mean to say many people talk about curiosity as a hunt for something, and or the curious people in this kind of Western culture as hunters. So this language is in the texts in multiple languages. So that's where I'm drawing the titles of these archetypes. But the hunter is very focused, has a few things that one or two things that they really like to zero in on, and they want to know a lot about that. And otherwise they're sort of bored, right? But those things, they're what they're ready to talk about, they're ready to investigate. Let's just stay there. And they tend to build, at least as we've talked about it, much tighter knowledge networks where a lot of the connections are filled in compared to the busybody, who doesn't need a lot of connections filled in for their web. And then the third archetype is the dancer. And the dancer is somebody who takes leaps of creative imagination. And there I follow typically the language of leaping. So there is some language of dancing in relationship to curiosity in these texts, but a lot of language of leaping. And the leap is this moment of creative imagination. I'm here, I know this, what if I jump over here and build this new connection? What happens to my knowledge network then? What can I think? What can I do in the world? What can I create? So the dancer is the creative of the three.
Yeah, with those three archetypes, I really understood the busybody and then the hunter. And I was slightly confused about the dancer and how they gather knowledge. You're talking about like leaps and things like that. Are these the individuals? These are like super creative types, I'm guessing, is probably what you're getting at here with the dancer, the learning style, where they're kind of a bit scattered, but then they like connect all these diverse points. Am I kind of hitting on that correct? Or
yeah, or you can think about it in relationship to sort of anyone who learns a field or has a career. So you have to start you have to start out in a career or in a field by learning a lot about a lot of different things, right? You take all of these classes or you have all of this experience, and then you start to focus in, say, okay, this is my area, this is where I'm going to drill down, this is where I'm going to develop expertise. So you start more as this busybody structure, you zero in as the hunter, and then the longer that you're in a field or in a career, you get to know areas of that field or career that need to be changed, that need to be reimagined. And it's at that moment that you can access sort of the dancer-like curiosity to say, okay, what if I change? What if I put, an original idea, if I change a concept, if I reimagine a practice, and let's do it differently. Let's take all those edges off that haven't been working and redo them. So the dancer is that last moment of sort of creative change, which I think is not, it does mark artists, certainly, but I think it could mark any of us, really.
So is it fair to say that this dancer curiosity is like an epiphany or a eureka moment type of situation? Or is it something more deliberate where you are so learned within a particular area, you're like, well, let's now play around with it and see what I come up with?
Yeah, I think it could be either. When I think about books about sort of the creative life, there are certain everyday practices that can invite this creativity in which it's not really a particularly eureka moment, but you show up with an openness to looking at something sort of cockeyed
Okay.
and askew and seeing it, oh, wow, you know what? There's a different path here that folks are missing and that I was missing, and I'm going to follow that out. Dani, I don't know if you want to fill out the dancer any further.
Yeah, no, I was definitely going to agree with you that I think that the dancer could either be this like very short time scale epiphany aha moment, or a longer time scale wrestling with two things that just kind of don't gel right now, or that might gel differently in the future. Maybe I'll give another illustration. Perry, I liked yours about the sort of career. I'll give another illustration of how this happens in scientific research. So and scientific discovery. So at the very beginning of a project, any project in the lab, we will typically read a lot around the space, and we'll go to conferences and listen to a lot of talks that are given in that space. Maybe we'll read some books, some articles, we'll talk to people. A lot of it is busybody-like curiosity. And then once we've identified the question that we're most excited about answering and really drilled down to say, here's the specific hypothesis that we want to test, then we become more hunter-like and seek for information about the answer to test the answer to the question, or testing the hypothesis with particular experiments. That's much more focused, much more hunter-like seeking of information. And then when we're done and we've got an answer, we always want to ask the question of, so what? So what? Now we have an answer. What did that do? Where did it get us? And in answering the so what, you have to say, because we've found this, because we've discovered this, that means this about some other field. It means this about medicine. It means this about how to treat patients. It means this about the universe. So it's understanding and unpacking the kind of so what of a hunter-like curiosity is, I think, what the dancer can do. And at a broad scale, that's interdisciplinary work. It's like, how does this relate to another discipline? But even at the more local scale, it's just asking, how does this new piece change kind of the landscape around it, and alter how we think more generally?
Okay, I understand better now. Yeah, those analogies definitely help. And I didn't think that they were related at first. I thought that they were just like different distinct learning styles that you had identified. I think, Perry, this was your chapter that you wrote, that you had identified these three different styles. I didn't realize that like one essentially evolves into another. Like it's just a series of steps between the different types of curiosity or knowledge networks here, as you go deeper into a specific topic. So you start off as a busybody, as you said, Perry, and then you kind of evolve into the hunter, and then eventually to the dancer as you become more refined. And then you want to make these connections at some point, or these connections are made by themselves at some point when you become the dancer.
Yeah, and maybe, oh, so Perry, you're gonna say something?
No, go ahead.
I was just gonna say that it's also these examples that we just gave moved through those three in that particular fashion, but I don't think that we hold that that's the only way in which they can be used, that they could be mixed and matched. You could move through them differently. You can pop out into the busybody at any point in whatever career or research project you're in. And so that's one point, that they don't have to go in this order, but sometimes that order is really understandable. I think it's easy to come up with examples for how we do that.
Okay.
The second point I think I want to make is that those three are key, obviously, from a historical point of view, but they're also not the only styles that we think are important. And Perry, maybe you want to just mention some of the others.
Yeah, so we've just had a blast of a time. You know, anytime that someone says there's three and only three of something, you say, well, that's impossible, right? There must be more than three archetypes of curiosity. And that's part of what's exciting for us. We want this to be the beginning of a conversation about styles of curiosity, because we really believe there's more out there, and the more that we know about these styles, the better we can facilitate and access curiosity in ourselves and in each other in a variety of settings. So one of the places that we've gone is to turn to animals. And so that we have an appendix of the book in which we talk about 18 different animals, which is just the beginning. We have notes on many more. This is sort of a pastime at this point. But to think about animals and insects and other creatures and how they're exploring their world whether scientifically, right, how we actually observe their behaviors, or how they behave in literatures, fables, stories that we've inherited, and how these tell us ways of being curious that we may not necessarily recognize or celebrate among us as humans, but maybe we should, right? And maybe they offer a much wider swath than the busybody, hunter, dancer triptych.
Yeah, that's another question I was actually going to ask at some point is how did you narrow in on these three archetypes? Because you just said there's more. So why were these the most important, I suppose? Why did these float to the top based off of all of your observations from the research and the literature?
Yeah, I would say that they were the most pronounced, where the
Yeah.
words were repeated the most often. People kind of returned to these and echoed prior authors on these kind of three styles. In scientific terms, there was evidence of other sorts of styles, but the evidence was a lot noisier, and it was difficult to kind of pull out and distinguish what it was that was being talked about there. So I think there's more work that could be done from the historical philosophical perspective to draw more styles out of the histories, as much as, also turning to other archives.
Okay. Well, there's more work to be done, like you said, and we'll see eventually what comes to light.
Yep.
One of the things that I thought was fascinating, and I love this about your book too, is that besides the beautiful artwork that you have at the beginning of every chapter, which is just wonderful, by the way, I thoroughly enjoyed it. But you also have network diagrams, and some of them are just like hand sketches, and which I think is wonderful. And when you're describing the three archetypes, I remember there was a diagram on one of the pages where you have the busybody diagram and juxtaposed with it is the hunter diagram. And you have these networks, so the busybody can be looked at as a longer network, and then you have these nodes interconnected, spread out. So these are all the various points that you're pulling from. You don't actually know knowledge on a deeper level yet, but you know it in a wider level. And then you have the hunter network, which is very dense, like one of the small world networks. So you have a lot of nodes, and it's very deep. I just thought that was a very, very illustrative of what you were trying to describe with those three archetypes. And I know the dancer wasn't there, but I could probably imagine, or maybe I missed it, but I probably could imagine that the dancer would just be if you were to go through the transition from a busybody to a hunter and then to the dancer. So these moments where you're restructuring the graphs, so you're taking an existing graph and you're either removing edges or you're adding them and building a more streamlined, let's say, sort of graph. I don't know, is that kind
Yes.
of pictorially
Yes.
accurate?
Yes, it is. And it's also, I love the fact that you're calling out the dancer as the one that allows for kind of a change in the shape of the network. And that's exactly what we think that the dancer is doing. It might need to remove some edges, it might need to add some edges, but it allows for a reshaping. And this is sometimes hard to have a picture of in your mind, because often when we think of networks, we think of something like a scaffold that we would see on the side of a building that's getting rebuilt or refurbished or something. And those scaffolds are very rigid, right? They're very boxy and rectangular and etc. And they're so rigid, that's their point, so that when people climb up on them to do the work on the side of the building, they don't fall down, right? Mm-hmm. But I think in our knowledge networks, there's a potential for you to create a connected architecture that would move, that would have some flexibility, and that would not be rigid. And this is illustrated by these wonderful Danish sculptures called the Strand Beasts. And these are sculptures that are created out of piping and wood and canvas, where the sculptor, Theo Jansen, he connects pieces up together with one another in such a way that when the wind blows in a particular direction, it will move certain pieces and it will mechanically allow the Strand Beast to walk across a beach next to the ocean. And it's that kind of movement or that kind of reshaping of a connective architecture that I think is what the dancer does. So whenever I think about the dancer, I think of these Strand Beasts.
Okay. I know precisely what you're talking about,
Oh,
and
good.
those pieces of artwork those sculptures are just
They're beautiful.
are just beautiful. Yeah, they're absolutely beautiful and brilliant too in so many ways. Beautiful expression of artwork and one's own imagination and curiosity.
Yeah.
But while you were describing that, I had I suppose, a dancer moment or a bit of an epiphany of how, for those of people who are not familiar and are actually listening or watching, could visualize the networks that we're talking about, or a web of knowledge, is think of a spider web, and that each of the intersections, where you have the intersections, you have like a little node there, so that's some sort of piece, and that the linkages are the edges. That might be a great way for people to visualize what's going on here for those who are unfamiliar.
Yes, I love that. And I
So,
also want to point out that spiders, after they've built a web, sometimes they will eat sections of it or the entire thing and then rebuild it again. And that's a very extreme sense of the dancer, perhaps, but one that's relevant to the very end of our book, where we talk about cracking networks.
yeah, absolutely.
Well, and we
Go
also
ahead.
like
Go
to
ahead.
I think we also like to think about if the most recent spider webs you've seen probably have moments of rupture, right? Where a leaf has kind of come in and broken it, or a twig, or some stronger bee has actually flown through it and just sort of messed it up. And I think it's interesting to think about imperfect spider webs as the image of our knowledge networks, that there are constantly things in our knowledge networks that work. They help us figure things out in the world. They help us do science. They help us do philosophy. They help us do medicine. And then there are other sections that are just breaking down, right? That are no longer sort of working, whether for the field or for our practices with one another. And the invitation here is to find styles of curiosity that help us rebuild those sections, perhaps in new ways.
Yeah, absolutely. Nothing's perfect, right? We're always in this state of trying to be better, and in order to get there, you have to break down pre-existing networks or pre-existing frameworks. Not completely, maybe just a little bit, and then some of them have to completely go and build new ones. Yeah, yeah, absolutely. That's just kind of how life is, I guess. So is knowledge discrete, or is it a continuous? How should we look at it? So you have a chapter of the book where you dig really deep into the web of knowledge, and yeah, it starts off with talking about like how can we visualize it? Like how can we think about it? And yeah, so is knowledge discrete or continuous?
Yeah, this is where I suggest that knowledge is a lot like Swiss cheese in space. If you want to understand why I think it's Swiss cheese in space, I think you should read the book. But I do think that it's more than discrete. I think it is a connective structure. So it's not going back to these ideas of reductionism. To understand knowledge, I don't think we can solely understand the pieces of information that we're exposed to, but we have to understand how those pieces of information are related to one another and connected to one another. So knowledge is a connective structure. To see that, maybe for the audience members to see that in your everyday life, you can go onto Wikipedia, for example, which is an online encyclopedia, and you can look up one of your favorite topics, and you can realize that the words that are highlighted in blue are those that have a hyperlink, what's called a hyperlink, that will take you from that page to another page on another topic, a related topic. And that connective structure is kind of it's a imperfect reflection of the interconnected nature of knowledge in our collective minds. Any particular person, however, will have only a small set of those relationships. We might not all understand every possible hyperlink that could come out of a particular page. And so then I bring up Wikipedia not just to illustrate the connective structure of knowledge, but also because Wikipedia is what we then use to understand whether these archetypes of curiosity that have been present in the Western intellectual tradition for the last 2,000 years are also present today, Or the alternative hypothesis is that technology has ruined us all and we don't have any of the same curiosities that we had 2,000 years ago. Okay, so these are two competing approach or suggestions. What we do in collaboration with David Leiden-Staley, who's a professor at Annenberg School of Communication at Penn, is to have volunteers browse Wikipedia for 15 minutes a day for 21 days. And then we study which pages they went to and in what order. And we can, from that information, build up the networks that they walked on. Walking meaning like clicking through. And then from those networks, we can determine whether they're closer to the busybody or closer to the hunter. And so as an example of what this would look like, a person could start out on a page that is about rhododendrons, and then they might move to a page that's about oak leaf hydrangeas or winterberry or hollybush or some other bush that you would stick in front of your house. Or maybe mountain laurel. I love mountain laurel. But in any case, they're going between these different pages, and all of those pages are connected very tightly. That person would be a hunter. In contrast, there could be somebody who starts at mountain laurel and then goes to Queen Elizabeth and then moves to Minecraft. Now, those are really distinct pages, very, very different ideas. And maybe there's something about the Queen of England that reminded them of Minecraft. Maybe there's something about mountain laurel that reminded them of the Queen of England. We don't know, but they move through these very different pages, and that's more the busybody. So what we can do from watching people walk through Wikipedia is that we can see that there are some people who are very busybody-like, and then there are other people who are very hunter-like, and there are lots of people who are in between, who are like kind of, half and half. So this illustrates to us that these archetypes of curiosity that Perry has excavated from the historical philosophical literature are present today, and technology hasn't ruined us all. The second thing that we learned from that study is that people who are busybodies on one day tend to be busybodies for 21 days. So there's something kind of trait-like about it, in the sense that a single person like me wouldn't typically start as a busybody and end as a hunter, or vice versa in this particular experiment. We'll start with one style and we'll kind of stick with it within some range. So we vary day to day a little bit, but we don't typically move from one end of the spectrum to the opposite end of the spectrum. So that suggests, I think, something important that complements an earlier part of our conversation. What this data suggests is that people might have a predisposition towards one particular style, and that they might use that regularly through many of their days. But that doesn't mean that, but it's also possible that in particular contexts, like the development of a scientific argument or discovery, maybe we would move through 3 different styles in that specific context, but it might not be that all of those styles are ones that we would use in our regular life throughout the day. Does that make sense? So there's a distinction between kind of our typical style and what we might use a whole set of styles for a particular problem inside of our lives.
No, I definitely understand what you're saying, and I can relate it to my own life, because I know that when I'm naturally curious and able to explore things on my own, like say I have some leisure time and I'm interested about a certain topic, I'm definitely in busybody mode, where I'm just kind of gathering all this information. But when I go to do my research, I'm in hunter mode. When I started my research, I was in busybody mode. This goes back to the learning styles and the analogy you were using earlier, Dani. Yeah, when I do my own research, I'm in hunter mode, because I'm already refined on the problem, know exactly what I'm doing. So I'm more concerned with my knowledge going deeper than I am being understanding the larger field at the moment.
Yeah.
But one thing I was curious about, you mentioned 21 days. So is that just the extent of the study, or is that this magic number 21 days kept popping up when you looked at the Wikipedia information, that people tend to just gravitate for 3 weeks in a particular style?
Yeah, it's a great question. So the 21 days was chosen because it's a reasonable time to ask people to be involved in a study that's daily, because we ask them to browse daily. So it's a big time commitment. And so we chose 21 days to be long enough that we could really see variation across days and weeks, but short enough that people would stay in the study and not drop out.
Okay.
So that's why we do 21 days. It's kind of an empirical set of constraints that determines it. But you're right that it's so that my claim that there's a style, we really only have evidence that that's the case for 3 weeks. And it's possible that if you go from year to year in someone's life, if I look at myself when I was 21 and then 28 and then 34 and then 40, maybe I would have different styles of curiosity at each of those ages. That's possible. And our study doesn't say one way or another whether that's the case. So I think that deserves more work in the future.
Yeah, still very interesting. And yeah, I'm excited to see what happens in the future. I can certainly appreciate too the fact that you have experimental constraints. So you're dealing with human beings, and of course, there are ethics involved with any sort of experimental setup, and also dealing with just how humans naturally behave. Sometimes they don't cooperate in the manner that you want them to, so you have to give them opportunity to do what they want to without walking away. Anyway, another topic that you were talking about within this particular chapter. So this is the Web of Knowledge chapter, that you had 3 particular, I don't want to call them archetypes, but you had mentioned 3 network shapes in particular. So you had like modular, lattice, and then random. And you said that it was one particular network type that was optimal for human learning. So I was hoping we could explore that.
Yeah, absolutely. So this is in work where we show people a stream of information, and then we ask whether they were able to detect the network structure underneath. And this helps us to understand whether there are certain kinds of network structures that are easier to learn than others. This actually relates back to the earlier part of our conversation on statistical learning, where the babies are being exposed to a stream of phonemes which comprise language. For us, what we are doing is that we are showing people a series of items or pieces of information and asking if they can learn the network structure underneath the pieces of items. What we find is that people respond more quickly and learn better when they're exposed to information in a modular structure. So that means where some items are related to one another rather densely, and another set of items are related to one another densely, and maybe there's a third set of items that are related to one another densely, and there are very few connections between those modules. And that's the kind of structure that people seem to be responding to very quickly and seem to be learning and understanding. So that's really interesting because it is both consistent with and informs the way that we give lectures in scientific spaces. So when I go to give a talk on my work at a scientific conference, I will typically separate my comments into 3 sections and say, here's some information about this idea, here's information about this idea, here's information about this idea. And then I draw some links between them so that it doesn't feel like 3 completely independent stories, right? But I spend significant time inside of each of them, inside each section, so that people really feel like that's a module that they've understood before we move on to the next one.
Now, with these 3 styles, did you start off with more styles, and then you kind of narrowed it down over the years of research, and you said that these are the 3 primary ones that you identified as being kind of being important, like that these are, out of everyone that we studied, these are the primary, these are the primary network shapes?
Yeah, no, that's a good question. So we did it because these 3 are sort of span the space of networks in an interesting way. The modular one is highly ordered.
Okay.
The lattice one is ordered in a 2-dimensional space or a lower dimensional space, and then the random one is random. So that's a nice kind of benchmark. And again, we had experimental constraints that we couldn't show 100 different networks because it would take too long for a single person to sort of sit down and go through all of them. So we had to choose a small number. But then I will say that in later work that was just recently published in the journal Nature Physics and was led by Christopher Lynn, who at the time was a graduate student in the lab, he showed that if we can actually computationally study a set of thousands upon thousands, I think it's 800 and some thousand network structures, and demonstrate that that modular graph is the one that is predicted to be easiest to learn based on our computational models. And so that helps us to then go back to the experiments where human volunteers are helping us and say, we know that this one is a boundary piece. This is an unusual structure that should be easiest to learn. Is it really true? And then span over to the random graph. So we have some evidence computationally that these are reasonable choices to be making.
Mm-hmm. And then experimentally, I don't recall whether or not you actually studied this from the book, yes, but I'm guessing that you studied it experimentally, and this is what you confirmed the computational work?
Yes, okay. We do. So that computational model fits the human behavioral data extremely well and explains all kinds of additional oddnesses, strangeties of human behavior. And it also is consistent with the fact that we find that humans learn the modular network best.
How did you actually test for that, for the speed of knowledge, I suppose, knowledge acquisition within a laboratory setting? I didn't dig into the paper personally.
Yeah.
I'm just curious though.
Yeah, so in a laboratory setting, what we will do is, so one of the challenges of trying to understand knowledge building in humans is that our participants are adults and they come in having a whole structure of knowledge in their minds already, right? And you don't know exactly what that structure is. So there's the issue of prior knowledge or prior information that can cloud what you then see in a laboratory experiment. So what we do to address that is to provide humans with information that they have no previous knowledge about. So that means it has to be kind of like a nonsense word or an image of a planet they've never seen or an alien culture, right? So these examples that I talked about earlier are ones that we can use because they are isolated pieces of information that humans shouldn't have been exposed to before. And in that space of new information, we can say, can we show you this information and do you learn the network structure underneath of it? So that's how we do it.
All right, very interesting. And something else that I found completely fascinating that you talked about within this particular chapter is you brought up statistical physics and the free energy principle. Yes. And how the mind tends to use that. And it's a balance of two pressures, which I can't recall at this moment, but I just found it fascinating.
Yeah. So it's a balance between computational complexity and accuracy. And so imagine that you want to be relatively accurate in responding to your world. That's important for you to survive. If you don't respond accurately to your world, then maybe you will make a decision that is not beneficial to you and could harm you, right? So you want to have a relatively accurate model of the world because that helps you to respond in a way that's good for your health, well-being, and survival. However, building accurate models of the world requires a lot of mental effort and requires you to hold in your mind a model that's really complicated. It has a lot of computational complexity. So these are these two pressures that sort of fight with one another. The more accurate you try to be in your model building, the more effort you have to expend. But you don't really like to spend a lot of effort. We are a system that tends to minimize energy expenditures. So you might want to move the computational complexity down, but then that pulls your accuracy down, right? And then you don't respond to your world in the most appropriate ways. So these two pieces are kind of competing with one another in your mind as you choose how to build models of the world. And each of us may come to a different kind of midpoint in that trade-off. Some of us are more accurate and expend more computational complexity. Some of us are less accurate and expend less effort.
So I just had a bit of a dancer moment where I was thinking about cognitive biases in the work of Daniel Kahneman and Amos Tversky, and they were talking about these systems of thinking. So you have systems 1 and systems 2, where the systems 1 is a more more deliberate, like it takes effort, and it's the more logical part of your mind. So this is where the more complex decisions would come from, versus system 2, or maybe I have it backwards. System 2 is the more where the heuristics and cognitive biases come from. It's your quicker, fast processing mind, and you're always in a competition between these two different systems. And when you're making a decision, you don't want to be overwhelmed by the quick, I don't want to call it illogical, but this is where the heuristics lie, the cognitive biases that can influence you negatively, versus the more deliberate systems 1. So you're talking about the statistical physics and these two different pressures where you're trying to figure out where the balance is between the complexity versus efficiency. I just was thinking about these two different systems that Tversky and Kahneman came up with.
Yeah, I think that's a really nice connection. And I've often thought about how this statistical physics theory relates to questions of bias, cognitive biases of all kinds, implicit and explicit biases related to the cultures that we've inherited or the systems that we exist in. I think that that's a space I would love to do more scholarly work in, and that's something you probably could tell from the book, is that that's the understanding of bias and the sort of lauding of marginalized voices is something that we're very committed to and discuss throughout. I don't know, Perry, if you have something to add there.
Yeah, I would just say that, in philosophy, we spend a lot of time not only practicing reason and deliberation, but also critiquing reason and deliberation. And I would just say that there's a lot of literature in philosophy that establishes bias is just as present in sort of intuitive, quick judgments as it is in long, drawn-out deliberations. So I don't know what kind of conversation there is between systems 1 and system 2 kind of relationships and this literature, but I would say that simply because we're using our executive functions and our reason and our deliberation doesn't necessarily mean we'll be less likely to employ bias in our assessments of the world.
Mm-hmm. Interesting. Well, I mean, perhaps somebody will explore it more, or maybe it's not worth exploring. I don't know. But yeah, I just had that kind of that sort of epiphany there where I was thinking about these two different pressures, and then the systems 1 versus systems 2 that was mentioned from Kahneman's work.
Yeah.
Anyway, when you're talking about networks, and there's an entire chapter devoted to this, but you mentioned the word walk quite a bit, and how when you see yourself positioned on a node, in order to get from one node to the next, you have an edge, but you need to walk, whether that is, whether you think of that from a actual literal physical standpoint or you're doing it in your mind, there needs to be some sort of connection. And I just thought the entire chapter that you devoted to the walk was like this deep philosophical exploration. And I understood, so I don't have a deep philosophical background to pull from, but I still found it very fascinating. And Perry, maybe we could just talk a little bit about that and why you actually felt the need to include this chapter just in general, yeah, like why you felt the philosophy was so important to include here with the walk and then the different types of walks that you explored philosophically.
Sure. The reason that we decided to include this chapter is because we've established at this point in the book a connectional network account of curiosity, and one of the common languages in network science of moving along a network is through a walk, right? And there are different sorts of walks, scientifically speaking, that we draw from graph theory, but walking. One walks on a network. One can track walks on a network. So that was already a really resonant word in a network account of curiosity. And on the other side, the philosophy of curiosity so often when I'm reading philosophies of curiosity, actual walking in the world comes up as a practice that facilitates a curious mind. So we just couldn't, why is it here? We couldn't not have it here,
Yeah.
this chapter. It was begging to be a thread that the two of us not only pulled out from our respective fields, but then kind of wove together. Yeah, so that particular chapter, I dig into a number of different kinds of walks. So it's not just, when I walk to the grocery store and I have one particular thing I need to get and I walk back. I mean, that kind of walk facilitates a particular state of mind that might have me curious about, is the thing I want at the grocery store going to be there, or am I going to have to go to a different grocery store, right? But then there are other sorts of walks that invite other states of mind that allow for literally other kinds of questions to live and breathe in our headspaces. So I think a lot about this long history of walking as intimately tied to the styles of curiosity we practice and the topics of curiosity we engage with.
Okay. Yeah, I know that I was reading through it, and I just thought it was really interesting because it's something that I'd never really thought about, how the environment influences your curiosity and the ways that you actually seek out information. So you're talking about you had the different archetypes. I don't think you call them archetypes, but you have like the three primary ones: philosophical, the spiritual, the environmental, and then the political. And yeah, I just found it was fascinating, and I particularly like the one on the environmental, just because I'm a huge nature person, and I definitely think differently when I'm out in nature versus, let's say, I'm sitting at home on my, at my desk doing my work, or if I'm out with friends and family or something like that. So yeah, my curiosity has definitely changed.
Yeah,
and the environment.
Yeah, and each of those kinds of walks, the philosophical, the spiritual, the environmental, or the political, engage in different literal geographical spaces, and they could have each been their own chapter, right? There's a lot of literature thinking about walking in connection with curiosity and or with thinking, but specifically in the environmental chapter, across environmental literatures, people are consistently writing about this, that the thoughts you can think when you're in a green space are significantly different than when you're not. And I think it was Walt Whitman in that particular section who said something about there are just ideas hanging on trees when he walks, and that the ideas themselves still have the earth attached to them. And that tells you, that's his poetic way of saying that there's an authenticity, I think, to the ideas available when you are, it's not just, you suddenly find yourself in a green space, but when you are in more intimate relationship with the earth on which we live. So if you have that, if you are in a relationship with the earth, and have that relationality happening, then the relational connections you can make between concepts and life are much more vibrant. I think that's what he's suggesting there.
Yeah, no, it's brilliant. Yeah, and it's definitely, again, thinking about all these different spaces that you can be in and just how it influences how you think. I can definitely relate, and it was a bit eye-opening because I never thought about it like that before at that level. So it's very interesting. But anyway, like we've had a number of different topics that we've talked on. It's all been wonderful. How can all of this information be used to shape education? You have a section towards the end of the book, you talk about this. So yeah, how can we use it to reshape, to reimagine education?
Yeah, I think the short version is, if we redefine curiosity as a capacity for connection of ideas and people, and if we analyze the styles of curiosity, the styles of making connections in our knowledge systems and between people, then our educational settings become a much more a place of much greater variety. How people put ideas together, how they build their knowledge networks, what kind of knowledge networks they're bringing in, what kind of social values inform the structures of those knowledge networks they're bringing in, are so different, so disparate. And it means that in the classroom, we as facilitators of learning have I think a lot more work to do. Where I think we've been trained or sort of expected to educate in the way we may have been educated, although Dani and I weren't educated that way, but many people were, to just sort of, this is how you do it. This is how you learn. But really, I think we need to go back to the drawing board and say, how do you learn, right? We're in a state where we need to figure that out a lot more so that we can just help facilitate how you are already, your own curious self. And I know Dani has a lot to say here about specific ways we typically expect curiosity to show up that that don't cover all the bases.
Yeah, I have a favorite example from a recent class that I taught, where I required essays from the students, and the typical essay obviously has a very specific structure. It starts with an introduction, it has methods, results, discussion, it has particular spaces for particular kinds of information. And the student submitted a paper that went through minutely every argument we had covered in the class, but as in the context of Alice in Wonderland. So Alice is talking to the Mad Hatter and to the White Rabbit and engaging with the Queen and doing all kinds of things in Wonderland, but illustrating and evincing and displaying the exact kinds of curiosity or of ideas that we had been describing in the class. And it was this sort of just mind-blowing piece, not like anything you would expect to get in a course of this kind, but one of the just most fun things to read. So I love it when students have space. Like, I think it's incumbent upon us as professors or as teachers or leaders or facilitators to provide spaces where people can show the kinds of curiosity that they have, and where that kind of curiosity can be validated and can be valued and understood and seen. We don't all have to fit in boxes. There aren't enough boxes for all of us.
Yeah, and that's definitely something I think that happens in the traditional education system. And I know that people have been talking about this for a long time now, where there are definitely different learning styles. There's clearly different curiosity styles, and one style is not going to fit every student. And if you just have the one style, you're going to be elevating just one type of student, more or less, that has that particular learning or curiosity style, and leaving others behind where they don't necessarily need to, well, they shouldn't be left behind, number one, but maybe the reason they're being left behind is just because you're not appealing to their curiosity style. So yeah, I mean, it definitely needs to be reimagined. There needs to have some dancer moments there where the network, the education network is restructured and refined, removing some of those edges, building new ones. I categorically agree. I couldn't agree. Yeah, it absolutely needs to be done. So going back to finishing up, the education, and then you conclude with, what's the word I'm looking for?
Cracks.
That's it. Thank you so much. It wasn't coming to mind. I got confused for a second. All right, yes, cracks. Let's quickly touch on cracks.
Yeah, we had fun with this one. I mean, this is I think most experimental chapter. We wanted to explore what we could do stylistically and also conceptually, and we wanted to mess with a little bit what we had done in the book, in the way that any curious mind must. And the whole book itself is focused on building, connecting, building connections all the way through every chapter. This is what we think curiosity is. And it was really important at the end to press home the fact that that also means breaking connections. Curiosity also needs to break connections. Even to make the connections it has to make, it may have to break other ones in order to do that. And so we call that cracks, and we fundamentally assert that curiosity has crackability, right? It inserts crackability into our worlds. Dani, do you want to add to that?
Yeah, just to say that cracking allows for a flexibility of mental spaces that's really important. So going back to the Strand Beasts and how I said that, there's a set of connections, but there's also a set of missing connections that allows for these Strand Beasts to walk along the beach when the wind blows. If that sculpture had been constructed in a lattice-like way, where every piece was connected to every other piece, no movement could happen. It would be fully rigid, right? It would have mechanical rigidity. And so the absence of connection is also is important for movement. And so fast forwarding then to the crack section, the idea is to underscore that for all of us, we want to have an open mind. We want to move in our knowledge spaces into the future in different ways that will require a flexibility, and that the movement and flexibility will require cracking or breaking connections that we've had in the past. And that's important for what we could envision for a new world in the future.
Absolutely. Couldn't agree more. Anyway, Dani, Perry, it's been an absolutely fantastic conversation. I learned a ton. I think your book's phenomenal. Well done. Where can people connect with you? Where can they find your book, your work?
The book is on MIT Press, and it's also on Amazon or Barnes & Noble or any of your favorite places to shop.
Including local bookstores.
Including local bookstores, yes. Not yet in the used book section, but
soon.
Yeah.
And then do you have websites, any social media where people can follow you, connect with you?
Yeah,
sure.
So I'm on Twitter at Dani S. Bassett, and my webpage is just through the University of Pennsylvania.
Okay.
I'm a quick Google away.
All right, wonderful.
Yeah, and I'm Perry Zurn on Twitter and perryzurn.com for the website.
All right, fantastic. Well, anyway, for all of those of you who have stopped by and are either watching or listening, thank you so much. It's been wonderful. Definitely stay tuned for more great content coming forward. Go ahead and hit that like button, share, and stay tuned. Until next time, take care.
Thanks.